Hi there. I wanted to create a video walkthrough of the Procedural Growing Trees asset pack. There is documentation provided in the repository itself to go through, and there's a website as well. But for those that prefer, the video will hopefully be useful. So I'm going to start by creating a folder to store the tree that I am going to work on today. Obviously, you can structure your projects however you choose. You might choose to put the tree parameters all in one place and leaf parameters all in one place. It would be fine, but I just like to create them all in one folder. And so then I'm going to, sorry, I breezed through that. I just went into Tools, Growing Trees, Tree Wizard. That opens the Tree Wizard, which basically is going to create a prefab for you to start working on your tree. All of this stuff can be created independently, but I put this wizard together just as a good starting point for those that are just starting out. And then you click this create new tree parameters. This is going to create an asset file which we'll use to configure the way the tree grows, the shape it forms as time goes on, and settings to do with time. Maybe you just want it to generate and exist a full tree straight away, or maybe you want it to generate over time. Maybe you want it to start halfway through and then grow. All of that's configurable, as well as how the attraction points which form the tree are formed, whether you want roots or not, whether you want it to grow slower in different seasons, and all sorts of things, but we'll get into that. So I create the demo tree asset. Once I've done that, I can click next. Then we want a material for the wood part of the tree. Both the leaves and the wood use the same shader, just because there were settings that I wanted to use on both, like the tessellations and the displacement, and it's good to be able to synchronize. Wind, I could have split them out into two shaders with some shared logic, but for now this is the simpler approach. Obviously, you can switch them out for your own shaders if you have stuff specific to your project, but I wanted to include something that had some nice features out of the box. So I'm going to call this our demo tree wood material. Then you choose if you're gonna have leaves or not. I think the only reason you probably wouldn't have leaves if you were doing a dead tree, or a burnt tree or something. I think most of the time you probably would choose to have leaves. So I'm going to click create new leaf parameters, and this is a slightly different structured set of settings, but that controls how the leaves are spawned. So the first one drives how the tree itself grows, and then the leaf parameters comes later and decides how the leaves are added onto the existing structure of the tree. And again, as I mentioned, we need a second material to drive the leaves. So create that demo tree leaves. Then this last checkbox enables seasonal color changes. Basically, if you were going to have an evergreen tree, you could turn this off. All it does is when it creates this prefab is there's a tree, and then underneath that there's leaves. This adds a component, a leaf color controller component, to the leaf object inside. If you change your mind later, you can remove it, you can add it, but basically that thing just goes. You've got a parameter there that you can set the time, and then it reads your leaf parameters and sets the color of the leaves appropriately. It means that if you have then baked the mesh later and you're not using the leaf parameters anymore, you're not using the tree parameters anymore, you've just got a mesh, you've still got something that controls the color of the leaves. So that's all that checkbox does. So I'm leaving it on because for this demo, I'm going to show a decent number of the features, and that will include seasonal leaf changes. So then I'm just going to give my prefab a name, and I'll pop it in the same folder with everything else. Great. Once that's done, we can close the wizard, and we will drag our demo tree into the scene. This is where we sort of play around with our tree, we get these parameters how we want them. So as you'll see here, it's added this tree mesh controller that has a few settings that we'll get into later, and this tree generator, which is essentially what we'll be playing around with now, that has the demo tree parameters attached. And you can see here there's quite a lot of different settings and things. What I'm going to change first is this initial growth cycles. I'm going to set this to 10. Basically, if I hadn't turned that on, actually, I'll just quickly demonstrate. If I set it back to 0, I go to the demo tree, I click initialize tree. Oh, sorry, I've got my gizmos turned off. And it creates these attraction points. The green dots up here, those are your attraction points for your canopy, so where the tree is going to grow up out of the ground. The yellow points are the points for your root system. And so when I had that initial growth set to 0, it doesn't spawn the tree, and then I click grow one step, and each of these is an iteration of the tree growing. Whereas for the sake of testing, I'm going to set this to sort of 10, and then when I click initialize tree, it's going to immediately go to 10 iterations, and we can see what a few different configurations look like. So we can play around with the settings and quickly look without having to constantly change the settings. I'll quickly run through a few of these. So the tree update frequency, this is when you have the game and play mode, you have this animate growth setting. And that will basically automatically do this grow one step every amount of time that you have set here. So that that'd be 2 seconds. And so you could have that set based on how quickly you want the tree to grow in the scene or not. Branch length, that's hopefully fairly self-explanatory. That's the length of each of these sort of parts of the tree. So I've got that set to 0.5 at the minute. Attraction range, that's how far away these green dots can be when it will influence one of these branches, when it will, they'll try and grow towards it from a distance of 5. Kill distance is, if it's within 1 of this attraction point, it will say, I'm close enough, I'm going to remove that attraction point, no longer grow towards it. Seed, so a seed is useful if you want to constantly generate the same tree. If you have it set to -1, it will always give you a random one. But if you set it to a static seed, it's always going to generate you the same tree again and again and again. It just configures the randomness. So it can be good for testing, can be good if you are baking the tree later. When we get into baking the tree, it can be good to test that way, but I'm going to have it as -1 just to demonstrate some of the variety you can get when it's completely random. So the growth, that this vigor, this essentially is saying as the tree ages, as the tree goes through those iterations that we were talking about, how much does it lose this vigor? It's basically a way of slowing down the amount the tree grows and then eventually stopping it when it reaches this minimum. So this is saying, it's still going to be 99.5% of its original vigor after 1 step, but then the next step it would be 99.5% of 99.5% and so on. So it would last quite a long time with these configurations. If you want it to die off quicker, you could lower this number, raise this number. If you didn't want it to die ever, you'd have this set as 1. I wouldn't mess around with more than 1 because it would basically grow faster the older the tree got. But maybe you want that in certain circumstances, so I've left it as able to be done. This tree upward bias, trunk upward bias, basically says from 0 to 1, how much does the trunk want to grow straight upwards? So at the minute we had it as 1, this trunk is set to go straight up, but if we set it to a much lower number, 0.4, something like that, when we initialize the tree, we get much more wonky trunks. Maybe a bit more realistic in some scenarios, but there are some trees that do tend to grow straight up, like your pine trees and stuff like that. Then your initial trunk thickness is the thickness of the first branch that it spawns, so how thick this initial branch is, and how much this thickness fall off is how much each subsequent branch that spawns out of that branch is smaller than the last one. So 70% smaller. No, sorry. how much of that, how big that branch is compared to the last one. So at the moment, the next one would then be exactly the same size, or much smaller. 10% the size nearly. And I have it set to 0.7. Basically, just says that each time it grows, it gets a bit smaller, 30% smaller. Child thickness fall off. This is for your subsequent side branches. So this 70% applies to the main branch. So here, when you're growing up the trunk, each of these only has one children. But then when you go into these sort of side branches, you can see here this one has split into 3 different directions, and then this one has then subsequently split into 3 different directions. I don't know if you can see here, this one's thicker because that would be the original branch. That one had the 70%, and then each of these subsequent ones then goes 70% of that 70%. So how big are the side branches compared to the main branch, if that makes sense. Again, if any of this doesn't make sense, there's a Discord. You can reach out to me. I'm more than happy to run anyone through it. Anyone has any problems, let me know. Then this thickness growth rate, that essentially ticks up to say, each step that the tree grows, how much do all of the branches grow in size. So if you can just see here, it looks like they're just getting a little bit smaller because we have that set to 0.01. I mean, if you set it to a massive value like 1, then each time they'd get much bigger, and obviously you wouldn't do something like that in real life. But I just wanted to demonstrate there what that did. Then this min branching thickness, that says how thick does that branch have to be before it be considered for making more branches. So these tiny branches here, they're probably not big enough to grow more branches, but if we made it smaller, then we'd probably see these much more spindly branches coming out. And for some trees, you might want something like that. If you were doing like a birch tree where they do have quite spindly little branches, you might want to set that to a low value. Or if you wanted, a big tree like a redwood or something that doesn't have as many branches, and the branches that it does have are much thicker, then you'd want that set to a higher value. This max branch thickness ratio essentially is saying how much thicker a child branch is a parent branch, is allowed to be compared to its thickest child. And so it's essentially saying it's driving the thickness of branches after a branch to sort of keep the tree in a sort of consistent shape, preventing as much these big dramatic drops in thickness. Max branch children, hopefully that's self-explanatory. It basically says how many times a branch is allowed to split. You could set this to -1, so it could be infinite, but then you can end up with sort of like fans of branches where one branch might have split 10, 15 times into loads and loads of different individual branches. Not sure why you'd want to do that, but perhaps you would. This min branching height sets the height at which below the 0 point, which is where the trunk meets the roots, or if you haven't got roots turned on, just the trunk meets the floor, I suppose. How much above that height do you have to be before it will start branching? If you have it set to 0, it could start branching straight away. But if you want branches to only appear after 3 meters up, then you can set that, and it won't start branching until it gets higher up. There you go. So you had to get to sort of that height before it would start splitting off. It was just 1 prior to that. These scale rates, they essentially are saying how much in each iteration the tree should grow in a particular direction. So if we have a huge horizontal scale rate, it's going to get wider very quickly. And then obviously, same with the vertical, it will get taller very quickly. Then this is how you choose these green dots and how they spawn. You can choose between a spherical or a conic canopy. By the canopy, I basically mean the sort of dome on top of the tree. You know, where are the branches growing? Are they growing around in a cone, or are they growing out in a sphere? And where is that centered? So this taper factor, it only affects the cone shape. It's how much it comes into a point towards the top, and how wide it gets. Well, I guess, yeah, so it goes from being a cylinder basically to an actual cone. Max crown points, how many of these points are allowed to be on the tree at any given time. You could set loads of them, and then it would spawn. Oh, sorry. Well, it basically, when it reaches that that limit, it starts to cull them off. But then it actually only spawns a certain number per step, and so it's unlikely to reach a large number unless they are spawning very far away from the tree and they're not being reached. But I limit it to a certain degree just because it could get bad performance wise if you have too many of these things. So if we did have a high value like 1,000, and then we were also spawning sort of 500 at every step, then well, it's still not noticeable, but the performance in theory would be worse, especially if you had lots of these trees. So I mean, play around with these things. Your system may be capable of different things, but obviously, you know, your users may have different things as well. Obviously, I think as well it will be because of our kill distance that we're not seeing lots and lots, and because we have only a very small initial crown. Actually, so yeah, so if I set that to a high value, and then set the crown radius very high as well, then we should see. Yeah, well, I set it too high potentially, but these dots are now going all sorts of different places, and there's lots and lots of them, and that could be impacting performance, at least eventually. So I'll set that back down to a reasonable level. But this, yeah, so this initial crown radius is the sort of radius around the tree, how far away these things can spawn. The initial is right at the beginning. The max is when the tree is fully fledged. How far, how big, and how wide do you want it to be? You could make it huge, or you could have it be smaller, depending on the sort of tree you want to generate. This crown horizontal expand speed is saying how much it should transition each step from this initial crown speed to this max crown speed. And then same again for height, same concept here. So how big does it start off? How big is it when is it its max part size? How much does it grow each step? This canopy depth sets where the canopy is from. So basically, the radius and the height are both set from the top of the tree. And so if you have it as a sphere, does it come down to the bottom of the tree? So that's when this is set to 1. Or does it only come down to 80% of the tree? Basically, it doesn't affect the height, it doesn't affect the radius, but it does prevent it from drawing too low to the ground as the tree gets bigger. Otherwise, you know, if the canopy height was set to 50 and the tree was only 5 high, without this canopy depth set to, you know, if you had it set to 50 as well, you'd get these attraction points being grown underground, and the branches would try to go underground, and it would look strange. So that's what that does. Then we go on to the root system, and we just show what we're looking at the minute. This is what we've done in terms of more spawn points, wider, larger spawn volume on top, and then the roots we haven't touched yet. So we've still got the small roots from the beginning, from the default settings. So what do the roots do? You've got two settings here, one to enable them and the taproot. So the taproot is this thing here. It's currently growing a bit unrealistically long. I think it's currently set to just be the same as the height of the tree, but underground. But basically, the way that most trees grow is they'll have a large bundle of roots along the surface for growing, for pulling their water and their nutrients, and then they'll have a taproot which digs deep and is used as sort of like an anchor to hold the tree in place. And so that's what those two things are. You can turn them both off, and so then they won't exist. But with them on, yeah, they show up, and then you can change, very similar to the crown, but we're now changing the points, the yellow points that spawn for the roots. So the depth factor that sets, I'm not getting a tooltip for that. Maybe I haven't. I'll double check that I actually did that, because most of these should have tooltips. But the taproot depth factor is as a percentage of the tree height. How deep should the roots go? Then max number of root points. Number of root points to spawn per step. We can turn that up a bit. The initial radius of the roots, and I mean, these are very much the same as the canopy ones. And then yeah, these last two you can set a ratio so that rather than having your growth on both, you set your growth as a proportion of the canopy. So you could say, I want the roots to actually grow much wider than the canopy. And so as time goes on, they'll spread out. Or much deeper, or whatever. You configure your roots. On these maximums, I probably didn't actually change the, yeah, that was probably, yeah, so then you can see the roots growing right out, much wider than the canopy of the tree eventually. I wouldn't try rendering something like this. This is, well, depending on your settings. The more complicated you get, obviously, the harder it's going to be to render. We'll get onto the rendering settings in a bit. We'll just finish up with the tree here. We're pretty much done with the root system, and so then we look at pruning. So pruning is where you can see these red roots and red branches, as well as, so actually I'm skipping. Well, so yeah, that's that enable pruning that will cut off branches that have been inactive for 15 steps. So if the branch hasn't grown in any direction for 15 steps, it's not even been attracted by any of these points, so it's not being drawn by these points, there are other branches that are meeting their requirements better, it will essentially lose those branches will die off, and so they won't be rendered. They're still rendered as red just to show them, but when we actually get to rendering, the mesh won't be created for those ones. And if they were rendered in the past, they'll be deleted. Attraction point pruning is essentially saying if you had this kill distance set to 1, but you actually wanted to get rid of a load of attraction points, maybe you had too many of them, and you wanted to set that to some lower value than your kill distance. So the kill distance would be done in the first step as the branches are growing, and then there's a later step, this pruning step, which essentially says, oh, well, this branch is already kind of close. I'm going to have the prune distance at 2. I'm going to get rid of all of the ones that are at 2, and we're going to spawn new ones and only consider ones that are further away. Then there's this check for shade. Shading is obviously a bit more advanced because it depends on what you've got on the scene, and obviously it will only really work either if you're making the effort to to pre-bake something, or if you're having all of this stuff run at runtime, and if you have lots of these trees running at runtime, oops, shouldn't have done. Let's set that back to 1. Then it can get a bit slow. But let's actually set this to more like, yeah. But for those that like the realism, I added this shading. So what it does basically is you set a shade layer mask. I set this to everything. Check for shades, turn that on. Check for shade distance. I'm going to turn that to like 100. That's basically how far it's going to check to see if it's shaded. And then when I reinitialize my tree, it's gonna, yeah, it's sort of split, because all of these attraction points are being shaded by the thing that we've got above it, and so it's sort of split to be attracted to either side of it. I hope that makes sense. Then the last setting that we have on our tree. Oh, actually, sorry, I hadn't got to the seasons. Is where you want to prune the attraction points based on the tree height. So as we grow up, you might want to remove lower down ones, just because you want the tree to grow upwards rather than across the ground. Some trees do grow across the ground, so you could probably set this to 0 if you wanted, or you might want something like a redwood, which would only grow branches really towards its top portion, based on, well, where the light is and where the light in the rest of the forest is. And so you might want to set this to a very high value. And then the seasons at the end here, that's just how that, sorry, for a tree, that just affects how much it's going to grow. So when you've got it set to automatic, you've got the it's in play mode and it's just running automatically. It will grow faster in the summer and it will slow down in the winter. So you can turn that on or off based on what you want. And then here you set the time of year, and that will tell it whether it should be growing at its maximum speed or whether it should be growing at some reduced speed, based on, yeah, what time the year you're in. You could also use that to set sort of sunlight values. Then I think that's everything for the tree parameters. And so the next thing to look at is the mesh controllers. So I'm going to enter play mode. And for now, I'm going to turn off animate growth, because that's going to grow the tree every 2 seconds. Now, when I press initialize tree, it not only does it create our tree as we were before, but it actually also renders this sort of default tree underneath. At the moment, the leaves are spawning in the shaded area. We'll come back to shading shortly, but I'll just run through the 5 parameters that both the mesh controllers have. So basically, the way that the underlying tree, the tree structure that we were drawing before, is rendered is rendered through either a marching cube or marching tetrahedra compute shader, and so it can miss bits, it can come up with all sorts of different shapes, and so this is what this is for. If you want to have it be more specific, you can set the voxel size to, well, you can set it to much larger and then you miss most of the points, or you can set it to smaller and it will obviously be more computationally expensive, but it won't miss, you won't get those gaps. A little thing that I've put in to deal with the performance issue of having smaller voxel sizes is this surface offset. So you can basically make the tree wider across the whole thing, in order for it to all be detected by the marching tetrahedral marching cubes algorithm, whichever one you've chosen to use, and then you can shrink it back down. So that way you kind of get a bit of the best of both worlds. You can have a smaller voxel size, a larger voxel size, which is easier on the computator, and then use the surface offset to make parts a bit wider so it's all detected, and then shrink it back down so that you get the spindly bits again. Then there are these two settings. So there's reduced vertex count. What that basically does is post-processing on the mesh itself. So when that's turned off, when the mesh comes out of the compute shader, obviously each of these triangles, there'll be three vertices, but for this triangle here, there'll also be those same three vertices. This goes across all of those vertices, and if I turn the smooth normals off for a second, it might be easier to see. Not particularly. It basically melds those together, and so that one, sorry, that one vertice here is shared between its neighboring triangles. So it reduces the vertex count quite considerably, makes them easier to render, and also changes the appearance slightly. So if you don't have smooth normals on, you basically get these triangles, which at the moment don't look like they're reflecting the light properly. I think the normals that come out of the tetrahedra shader probably need adjustment, and so that's what the smooth normals does. It goes across and recalculates all of those normals, and then the reduced vertex count, as I said already. But yeah, I think you can play around with these and see what's different. I think for the leaves, it really does make quite a difference. So I tend to have them both turned off because you get this more realistic looking leafy effect. But if you want, you can turn the reduced vertex count on. Yeah. And you get this more sort of fluffy effect. And then if you have the smooth normals as well, then you get this really sort of low poly style fluffy effect. And so you can really play around with the different appearances of the leaves based on just those settings. And then obviously, yeah, they're the same. It's got the same things where you can shrink them back, change the voxel sizes and surface offsets. The leaves are rendered in the same way. But what we haven't looked at yet is the leaf settings. So there's a few ways. Well, there's two main ways that you can spawn the leaves. Uniform basically just spawns it across the whole tree, regardless of any sort of shading. But if you want to have the leaves shaded in the same way as the shading that we added to these control points for the way that the tree is grown, you can just have it on realistic, and then in the realistic mode settings, you set the shading tech distance and the layer mask in the same way as you did before, and then you just have to change the time to update, or if you grow one step, it'll update as well. But it doesn't check every single parameter to know that it should update, because it's just a few things to check. So yeah, then you end up with the leaves only rendering where they're essentially getting sunlight, and so the tree's being attracted this way because it can get to the light, but it's not growing any leaves yet. Then you can set other settings. So this leafiness essentially is how big and fluffy the leaves are compared to the branches. Oh, sorry. Yeah, there we go. So with a low leafiness value, they're much closer to the tree itself, and then with a really high leafiness value, then they come out like big balls. Yeah, I would just play around with those just to get something that fits in with the style that you're after. Leaf coverage, hopefully that's self-explanatory. I will turn off the shading just so that we have full coverage, because it makes it easier. And then leaf coverage, that essentially just randomly selects a load of points to remove. And it does make sure that it sets the same one every time, but if you grow, it will change slightly just because the points are no longer the same, and so the random number generator won't necessarily pick exactly the same ones. Then a leaf start height, so that's a raw value that just says below 0.2 we don't spawn any leaves below that point. Leaf start height proportion says, as a proportion of the height of the entire tree, so as the tree grows, we don't spawn leaves below this point. So when you've got it set to 10%, or that's not made any difference, but if it was sort of 50%, then yeah, it cuts all of the leaves off below that point. Drooping leaves, this is a sort of like viney type thing. So these sort of hang from your, I might need to make them a bit bigger just so that they're visible. I'll make them sort of 3 in length and 1 in radius. I use them for sort of willow trees and birch trees and things where you have the sort of leaves hanging down. And so you can play around with the radius of them, play around with the length of them, to get a look that you like with these drooping leaves. Then we've been over the shading stuff. Now we can go into the seasonal bits, and because we said our tree earlier is going to use seasons, we've got this leaf color controller set up, which controls the material and then also looks at our parameters. We can basically set these different values. So drops leaves, that's what we were seeing before about some of the leaves disappearing at certain points of time. It's basically saying, at what point do we start dropping leaves? When all the leaves drop by? When do we start regrowing the leaves? When are all the leaves regrown by? And so then basically, based on the time of the year, it will render some or all of the leaves. And then we can change the colors based on what you'd like at different times of the year. So you can basically, you set 2 colors and it creates a bit of a gradient, and then it creates a gradient between those gradients based on where you are in the time of the year. So we go for the more sort of orangey colors in autumn, and then we won't see. Actually, I'll turn the dropping leaves off for winter, and we'll go with like a blue just for a bit of fun. Because obviously normally you wouldn't see this because you'll have dropped your leaves by that time of the year, like this. You do just sort of catch them. I guess you have to play around with these values, but if you turn the drops leaves off, then yeah, you can see the full transition of all the different colors that you've configured based on the time of the year. Then there is a component that will control this. Later we can get into that in a minute. But before we do, I wanted to show the right, sorry for the abrupt cut. It was at this point in the video that I was supposed to talk about shaders, but I missed it last time, so I'll talk about them now. Both the tree and the leaves have the same shader, but obviously earlier we created separate materials for each so that we can change the settings independently. I'll just run through some of the examples. So when you're setting on your leaf mesh, your leaf parameters, your 2 colors on each edge of the gradient for the colors based on the season, that's what's setting these colors here. So you've got 2 colors that you're transitioning from and 2 colors that you're transitioning to, and then this slider basically moves where you are on that scale. I think that's still being set by the tree leaf color controller. I'll just disable that so that I can. There we go. So that's how you get this sort of gradient of these two different colors is those two different colors there, and then goes to these two different colors here based on that slider. And then we have the tessellation settings. So I don't know how many people are familiar with tessellation. There's a lot of videos out there to describe it, but basically when we output these models, the idea of, in order to get good performance out of the marching cube shader, we want to have a relatively low number of vertices, and so it comes out looking something like this. But if you wanted to, so I'm going to add some, I've got some example textures in the pack. These are just open source textures that were freely available online. So there's just a diffuse map, a normal map, a roughness map, but importantly a displacement map or a height map. So if I turn these on, you can see here, based on our current settings, there are, to a certain extent, when we have the displacement on, it looks okay, but you get some strange big juts out because it does these whole vertices. If you want it to be more specific, more fitting to this texture, you can increase the tessellation factor, which basically on a shader level increases the vertex count, so that when you are displacing it now, it's more specific. It looks like it's running along the texture, the seams of the textures more accurately. And so yeah, that's that. I mean, that's the only reason you'd use that on the bark shader. On the leaves, you might want to use the tessellation shader to get these leafy effects. So normally, if I turn the tessellation off, they're obviously quite a bit bigger. The higher the tessellation factor, the more that noise can impact. And then there's this noise frequency, which increases how many different leaf vertices there are. You can go right up to have some sort of really fluffy thing, and then you can turn the displacement up and down to have it grow out, or not be as dramatic. Yeah, so that's what those noise displacement, noise frequency, and then noise gravity sort of pulls them down in case you wanted sort of a droopier looking leaves. So they're sort of downwards pulled based on that, or just sticking out when you've got it turned off. So then tessellation smoothing, that impacts. There's a lerp between the way that the tessellation is done by default, where you're basically just drawing triangles within triangles within triangles, and smoothing pushes those triangles out closer to the edges to try and have the extra detail blending in different parts of the model. So playing around with that and the bias, they basically both just change the way that the tessellation looks. And so based on what you're trying to do, you might want to change those. But the main thing you want to do is change the tessellation factor. I normally leave this on constant. This tessellation mode would normally probably be used for the bark rather than the leaves. So when it's on constant, the tessellation factor is always 40. Well, I've got it to 41. You probably wouldn't normally have it as high as this. I think for most things, single digits is probably sufficient. Constant just means that it's always going to increase the number of vertices by 5. When you set it to the other values, it changes based on what part of the model is visible on the screen right now. So on world space, on screen space, and on world with depth, is essentially changing how those vertices are drawn based on what's on the screen right now. So it doesn't tessellate it as much if it's further away, or it will tessellate it more as it gets closer. That's what those different settings are for. But constant is just always the same. So if you had you wanted to use this at different levels of detail, then that's what you'd play around with. Then we've got these two settings here: frustum cold tolerance and backface cold tolerance. I'd just play around with these if parts of the model are being cold when they're on the screen. Basically, the tessellation shader needs to have a separate function in the shader to tell it when to cull these extra faces that are being generated when they're not on the camera, so that you're not rendering them all the time, because they're being generated at shader time. So rather than Unity handling the culling, you have to handle it in the shader itself, and so these settings will just change how tight the tolerance is on when those faces are being culled. So just play around with those settings only if it looks like faces are being culled while they're still visible in the camera, and so parts of the model are disappearing. I think these values have been fine for me, but if you have any issues, that's what they're for. Then we have roughness. That's fairly self-explanatory. If you wanted it to maybe look like it had got wet and it was rainy, you could turn the roughness right down, make the leaves look smooth. But normally, obviously, leaves don't look smooth and they don't look shiny and reflect the light. So I have the roughness relatively high. But you could make it glossy if you wanted. I don't know. Depends on the style of game you're doing. Normal strength only impacts the normal map. So if I switch back to the tree, you can change the normal strength, and that will change how much the impact of that normal map has. Essentially just makes it have more or less impact. This triplanar UV blending, basically the way that the so obviously normally when you have a shape that's textured, it would just be done on the X and Y axis, or well, there's normally essentially there's two channels for UVs, and so you can run into issues with when I have this turned off. You can have it look like there's more seams, I suppose, in the texture, where it's a 3D object with a 2D texture being applied to it. By using triplanar UVs, it sort of blends it in so that you've got it's more seamless over the 3D space, essentially. That's what that's doing. Then we've been through the textures. They're fairly standard. You can change the texture scale so that it's like smaller or much bigger. It's basically just what proportion of the tree space should be mapped to the texture space. I think that's fairly standard. And then we have some settings for wind. So I keep these the same for the leaves and the trees, because otherwise you could end up with the leaves that are blowing in one direction and the tree itself is blowing in another, and you start getting them sort of clipping through each other if you have it high enough, like that. So what you'd want to do is keep those in sync between the two. But this is basically so that you can simulate wind. You could obviously turn it off if you didn't want to. Didn't want to have it moving in the wind. But because trees do move in the wind, I decided to add it. You can change things like the frequency, which will make it affect more or less of the tree all in one go. If it's a low frequency, the whole tree will probably move together in unison. Whereas if it's quite a high frequency, if you've got a big tree, you might have different parts of the tree moving in slightly different ways as the noise moves across it. Then you've got the wind direction, which takes a 3D vector, so you can set where the wind's coming from, where it's going, the direction of the wind. Wind start height, I set that to 0, so basically it just 0 on the model is where the trunk meets the roots. And so we've got these drooping leaves on this model, so it's not immediately obvious. I can just turn the leaves off for now. But yeah, so 0 on the model is where the trunk meets the roots, and so that's where I've started the wind from. Basically just means that the wind doesn't affect the roots. If you change this value, you can change it to start at a higher height, and then it would be more static until a bit higher, or you could start it from a lower height, and then yeah, you would probably start seeing some of the roots bending in the wind. 0 is the default, and I think the one that makes the most sense, but you can customize it just in case you might have some different use case that calls for that. And then this last one is wind tension. It only really affects the displacement, so it would only affect the leaves, but basically this is saying if it's on 0, the leaves just sort of move all in unison, so the whole thing moves forward and back. When you've got a bit of tension in there, the ends, the tips of the leaves have a bit of drag, and so they get left behind as the mesh moves, to make it a little bit more realistic. Basically, that's the idea anyway. Recalculate normals is basically you pass in the normals are already set on the mesh. You can recalculate the normals in the shader itself for a more flat shading appearance. It's not immediately obvious on the leaves, but if I switch to the tree, it's also not immediately obvious. But it depends on which normals you've had configured. Yeah, you can kind of see a small difference here. You can see a bit more seaming there, I guess, because the ones generated on the mesh are smooth normals, and these ones are derivatives, so they should take into account the weight of the normals and the size of the different faces and things. And that's it. You can turn on GPU instancing. Instance materials should be supported. I've tried to. I've added those the necessary parts to pass through the instance information in the shader itself. The render queue and double-sided global illumination are URP shader variables that I haven't touched, so they should be the same as anywhere else. And so that is that's the shaders. Sorry, a bit unprofessional having this cut into the middle of the video. I should have spoken about this at the right time, but here we go. I've spoken about it now. Back to where I was before. Mesh baking. So basically, let's say we were happy with this tree now. This is a good tree that we want, but we don't want to use the runtime tree generation like we're doing here. As we can see, the performance isn't too bad. But you know, if we have loads and loads and loads of these trees, I probably wouldn't recommend having all of them grow. Maybe you'd only have a couple of them growing at real time. Depends on what else you've got in your scene. Depends on your game. Obviously, each game's going to be different. But you know, let's say you wanted to use this tool to design trees, but then you wanted to just take the mesh as is and not have them rendered through the marching cubes or marching tetrahedra compute shaders at real time. You want to bake the meshes and just have them in your game like normal assets. And so that's what we can do here. If you set this bake leaf dropping, what that'll do is it'll take from your leaf parameters, we've got this here, time of year re-render threshold. So I don't know if maybe those of you that may have noticed this, when I have drop leaves turned on, if I change this by less than this value, 0.05, whatever, it doesn't update. but when I change it by larger than that, it does update the number of mesh of the mesh that's rendered. Just because if you were to be using this as the real time rendering, it could get expensive if you had it updating all the time. You wouldn't want it to be drawing a new mesh every single frame, especially not if you had several of them. But what this will do is you have this turned on. This will take that value and it will go to the point in time when you start dropping leaves. It will draw one mesh where you've still got all the leaves, and then it will just increment that until it gets to the point where all the leaves are dropped by, and save each of those as meshes. It then just reverses. It doesn't save extra meshes for when they regrow. But I do have a controller that basically takes the meshes and based on the time of year, it just reverses that process to make them appear like they're regrowing with the same number of meshes. There's no need to save the regrowing meshes because the colors are done by a shader and the meshes are essentially the same. So back to the baker. So if I have baked leaves dropping turned on, optimize mesh, Unity has this built-in mesh utility optimized mesh. I don't know how effective it is, but essentially what that is running that Unity mesh utility optimized mesh on these meshes, which should hopefully improve the performance of them. I'm not sure. I'm already doing that pass, which reduces the number of vertices. So, yeah, obviously one thing to bear in mind is any of these parameters that you've got set down here on the tree mesh controllers for both the leaves and for the tree itself, they will get baked in. So you can't change those. Unlike the tree, the leaf parameters for color, which you can change on a baked mesh, the rest of that's this all gets locked in now at this point. So when I say test tree baked, I want to bake the leaves dropping. I want to optimize the mesh. I'm going to start it at 1, and I'm going to end it at 12. I'm going to do 12 iterations, 12 growth steps essentially, and then I just press the bake button. That's going to ask me a folder to put this in. I'm going to put it in my demo tree folder, and it's going to create 3 subfolders. One of those is going to be for the meshes for the tree. One of those is going to be for the meshes for the leaves, and one of those is going to be for the prefabs. So then what we can see here, the with a bit of a delay because it doesn't want to run it too quickly and end up sending multiple things to the compute shader before they're ready. It's basically going to start the tree at one iteration, and then go through each of those leaf dropping stages, saving the mesh each time. Then it's going to grow the tree another time, go through all of those steps again, and it's just going to iterate through that process until it's done. All of the iterations that we configured in the baker. So we'll just sit here and wait while it renders. Okay, that's finished. So then that's created a load of prefabs. Basically, it's got a bit of a naming system based on you've got the iteration and then the time of year that that prefab was created. What we can do now. So I'm going to create an empty game object. This is going to be our baked mesh controller. And in there, I'm going to drag in all of these prefabs that we created. Sorry. Turn them off so they're not all visible. Add our time passing animator. and our baked tree animator. Press the lock button, and then I'm going to select all of our meshes, drag them into the tree game objects. These names are important, so if you've renamed the prefabs, make sure they still end in these numbers. That's how it decides which ones to render. So the 1 or 2, that's the iteration number, and then the 08, 025, that's the time of year. And so that's how it knows which one to render at any given time. I'm then going to drag in the baked mesh tree animator and the respective leaf and tree parameters so that it can set the time of year appropriately. And then when I press play, it starts the animation. It goes through each of these. It's much quicker than if it was having to run the compute shader each time, because obviously all of these are baked already. And I know that we've created a pretty wacky tree here. Obviously, you can generate whatever you'd like tree-wise, and then when it gets to the final iteration, it's just gonna go through the seasons, and it's not going to grow anymore because it can't grow anymore. These are just meshes; they no longer have the controller attached, but it will still go through each of the seasons, the colors changing and the leaves growing and regrowing. I hope that answers any questions for someone who's just starting out with this. But again, please reach out to me on Discord. I'm more than happy to help with any problems anyone runs into. And if there's anything missing in the documentation, anything missing from this video, I'll make sure to go back and add to them either through notes in the description of this video, or obviously just updating the instructions that are included in the asset or on my website. Thanks very much. I really appreciate you listening, and any feedback is also much appreciated. I hope that this asset is useful for you in some way. I set it up because I did the classic thing of making a game that was too big for me to make on my own. So I took the trees that I had as part of this huge open world game that I had planned, and thought I'd release those separately. At least something can come out of all of that work. But yeah, thanks very much. I hope everyone has a good rest of your day. Cheers.